Hello my dear students, in continuation of our mark scoring videos for senior intermediate, today we will try to discuss short answer questions carrying 4 marks. So in the examination you are supposed to answer 6 short answer questions. So in this video I am going to discuss a few short answer questions. With the help of these questions you will be in a position to score 24 out of 24. So I am choosing the chapter Electric Charges and Fields, that is the 4th chapter. From this chapter you may get 3 questions. So according to the model paper given by the Board of Intermediate Education, so you will be scoring 12 marks. So each question carries 4 marks, that you will be that you are familiar. The first question is, state and explain Coulomb's inverse square law in electrostatics. It must be electrostatics, right? So Coulomb's inverse square law or Coulomb's inverse square law is found both in magnetism as well as in electrostatics, that is in electricity, right? Suppose we have two charges, charge Q1, charge Q2. They are separated by a distance d. If they are like charges, they will repel. If they are unlike charges, they will attract. So there is some electrostatic force acting between them. That can be force of attraction or that can be force of repulsion. So according to Coulomb's inverse square law, the force acting between the two charges, that is the electrostatic force, the force of attraction or repulsion, is directly proportional to the product of the magnitudes of the two charges. That is, F is directly proportional to Q1, Q2, the product of Q1 and Q2. Next, F is inversely proportional to the square of distance of separation. So F is proportional to 1 by d square. If you write these two as a statement, you will be getting around 2 marks. Is this clear? Right. Now, if I combine these two, then this will become F is proportional to Q1, Q2 by d square. Whenever there is a proportionality relationship, we will put a constant that you will be knowing. So that constant we write in this case as 1 by 4 pi epsilon naught Q1, Q2 by d square. So that's it. If you write this much, you will be getting 4 marks. But you are supposed to know what is this epsilon naught. Epsilon naught is called the permittivity of the free space. That's all. If you know this much, if you write this much, you will be getting 4 marks. No need to write the values of epsilon naught or no need to write the value of 1 by 4 pi epsilon naught. Write the statement in 2 lines and expressions, this 1, 2 and 3 and the final step. You will be getting 4 marks. So I will repeat, the force of attraction or repulsion between any two charges is directly proportional to the product of their charges, number 1. Number 2, inversely proportional to the square of the distance of separation between them. And the third point is that force acts along the line joining two charges. The third point is not necessary. Even if you don't write that point also, you will be getting 4 marks, right? We will go to the next question. Now, define intensity of electric field at a point, derive an expression for the intensity due to a point charge. Now, what do you mean by electric field? Suppose there is a charge Q. So, around this charge Q, you will find its influence. You will feel some force. Suppose this is the positive charge. If I place another positive charge, this will be repelled. So the space or the region around the charge in which its influence is felt is called as electric field. Now here there is no effect, so there is no electric field. Only within this circle, I will feel some effect of this charge Q. Now, how much effect or how much force is acting at a particular point? So that force is called intensity of electric field. So how to define? So in this electric field, I place a unit positive charge at a point P. I am placing a unit positive charge in the field of another charge, capital Q. Then how much force acts on this? That force is defined as intensity of electric field. So how to define? Intensity of electric field is the force experienced by a unit positive charge placed at a point in the field of some other charge. The intensity of electric field changes from point to point. It is not same at all the places in this case, right? So you have to define intensity of electric field. It is nothing but the force acting on a unit positive charge placed at a point in the electric field. E is defined as the intensity of electric field at that particular point. Is this clear? Right. If you write this much, you will be getting 1 mark. Now, the second part of the question is derive an expression for the intensity due to a point charge. Right. Very simple. So, what do you mean by a point charge? A charge of size point. It's a very small in size, infinitesimally small. Imagination, right? So, this charge is Q. Now, I want to find the intensity of electric field at a point P. So, intensity of electric field is indicated by E. It's a vector quantity. So, intensity of electric field is nothing but the force acting on the unit positive charge. So, what does it mean? I am placing a unit positive charge at point P. Let us say the distance between Q and P is R. The distance between Q and P is R. So, according to Coulomb's inverse square law, the formula for the force acting between two charges is 1 by 4 pi epsilon naught Q1 Q2 by R square. Here Q1 is my capital Q and Q2 is unit positive charge, that means 1. Substitute this. This force is nothing but intensity of electric field at point P. So, E is equal to, this will become 1 by 4 pi epsilon naught Q by R square. If you write this much, you will be getting 4 marks. Very simple. Scoring marks in the intermediate exam is so simple, but gaining knowledge is difficult. Is this clear? So, here our intention is to score. That is the reason why these are called mark scoring videos. Is this clear? So, intensity of electric field is nothing but the force acting on the unit positive charge placed at a particular point in the electric field. Is this clear? Right. Define intensity of electric field, definition 1 mark. Derive an expression for the intensity due to a point charge. Your point charge is Q, that is capital Q. Is this clear? If you derive this, you will be getting 4 marks. Let us go to the next question. Derive the equation for the couple acting on an electric dipole placed in a uniform electric field. What do you mean by uniform electric field? Just now I told you intensity of electric field changes from point to point because the distance changes, because E is inversely proportional to the square of the distance of separation. But there are electric fields in which E value remains constant at all the points. Then that field is called uniform electric field. If E value is changing, then that is called non-uniform electric field. Now in our question, derive the equation for the couple. You should know what do you mean by couple. Acting on electric dipole, this is the second one, placed in a uniform electric field. These are the 3 words you are supposed to understand. What are they? So third one I explained, uniform electric field. The field in which the intensity of electric field remains same at all the points. Draw. Next, for uniform electric field, field lines are parallel lines. Whether it may be a magnetic field lines or electric field lines. If the field is uniform, then field lines will be parallel. Is this clear? Right. So, third point is clear, I think. Next, let us go to the second point. What do you mean by an electric dipole? Di means two, poles means charges. Two equal and opposite charges. Two equal and opposite charges separated by a small distance, then that is called as an electric dipole. Di means two charges. What type of two charges? Having same magnitude. This is Q and that is Q. But they are not like charges, they are unlike charges. Equal and opposite charges are placed together with a small separation, then that is called as an electric dipole. Is this clear? Right. Only in atomic level only you will see an electric dipole. For example, you have water molecule. So, water molecule is slightly polarized. So, H plus, OH minus. Here the charges are same, but opposite signs. So, this combination is treated as an electric dipole. Is this clear? Right. So, second point is clear. Couple acting on a couple. What do you mean by couple? Couple means two, pair. If pair of forces acting at two different points on an object, what type of pair of forces? Those two forces must be parallel, number one. They must be equal in magnitude. This is number one, number two. And number three, they must be in opposite directions to each other. So, one force is acting here and another force is acting here. These two are parallel forces, equal in magnitude, opposite in direction. You might have studied in your first year. When two equal, opposite and parallel forces are acting at two different points on the object, then that object undergoes rotatory motion. That rotates. So, if I apply one force here, another force here, definitely it undergoes. Just like rotating the tap with the help of your two fingers, applying two equal and opposite forces. That is called couple. The expression for couple is equal to force into perpendicular distance between this pair of forces. So, two forces are acting. This is force 1 and this is force 2. The perpendicular distance is this one. They are parallel. This is called perpendicular distance. So, force multiplied by the perpendicular distance is called as couple. So, you should know these 3 points. These are vital points. Then only you will be in a position to answer the question. Now, I take a uniform electric field. For that purpose, I draw parallel lines. So, these are parallel lines. In this, I place an electric dipole. So, this is minus Q and this is plus Q. So, this plus Q is pulled towards this direction and this minus Q is pulled towards this direction, because electric lines are coming from positive charge and going towards the negative charge. That means there is a big positive charge on this side and a big negative charge on the other side. So, positive charge pulls this toward this and negative charge pulls the positive Q on the other side, right. So, this is acted upon a force equal to QE, where E is the intensity of electric field and it is same at all the points, right. And another force acts on this in this direction, that is F2 is equal to QE. So, both F1 and F2 are equal in magnitude, opposite in directions and parallel. So, couple acts. So, because of the couple, so it undergoes rotation. Is this clear? Now, what is the perpendicular distance between these two forces? So, one force is here and another force is here. You draw a perpendicular line making an angle 90 degrees. Let us say this is making an angle theta. That means electric dipole is initially placed such that it makes an angle theta with the intensity of electric field or with the field lines. Is this clear? Right. If this is theta, even this is also theta. From our definition of couple is equal to force into perpendicular distance. So force is how much? QE. What is the perpendicular distance? So this perpendicular distance I should calculate. I don't know. The length of the dipole is always taken as 2a. So this is 2a. I know the angle, I know this value, I don't know this value. Let us say this perpendicular distance is x. How to find the value of x? So take the sine theta. So sine theta is equal to, in this triangle, opposite is x and hypotenuse is 2a. So I know the perpendicular distance with the help of this right angle triangle, which comes out to be 2a sine theta. Substitute this here. So this is QE times 2a sine theta. I rearrange, I write this as 2aq times e sine theta. This 2aq is called the dipole moment of the electric dipole, indicated by P. So P is called the dipole moment. So C becomes P E sine theta. In vector notation, I can write this as C is equal to P cross E. If you write this much, that is enough to score 4 marks. Very simple. So you should know couple. You should be in a position to draw the diagram. Then you should derive 1 or 2 steps. Then you will be arriving at the final result. So is this clear? So question is this, and the answer is C is equal to P cross E. This is small p. P stands for dipole moment of the electric dipole. E stands for the intensity of the electric field. Is this clear? Right. Let us go to the next question. Derive an expression for the intensity of electric field at a point on the axial line of an electric dipole. Just now we discussed what do you mean by an electric dipole. This is an electric dipole having minus q and plus q. The length of the dipole is always taken as 2a because this is a and this is a, then the total length becomes 2a. That is the convention to take the length as 2a. Is this clear? Right. Now, there are two axes defined for an electric dipole. This axis, the imaginary line passing through the two charges, is called as axial line. The imaginary line passing through the center of the dipole and perpendicular to the axial line is called as equatorial line. You should be knowing these two. Axial line is along the axis, equatorial line perpendicular to the axis, passing through the center, the midpoint of the, what do you call, electric dipole. Is this clear? Right. So in this question, you are supposed to find the intensity of electric field at a point P on the axial line. So in order to find the intensity of electric field, you have to place a unit positive charge. You have to place a unit positive charge. Wherever you want to determine the intensity of electric field, at that point you have to put a unit positive charge. So you will be deriving the expression, right? Draw an electric dipole. This is, and my intention is to find the electric intensity of electric field on the axial line. So this distance is A and this distance is A. So simple. So extend this line. This is my axial line. I am choosing a point P where I am placing a unit positive charge. So this unit positive charge is repelled by this positive charge. Simultaneously, it is attracted by this one. So the small charge is attracted by this bigger positive and repelled by bigger positive and attracted by bigger negative. Unit means very, 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 very small. Is this clear? Right. So, two forces are acting. One force is due to this one. Let us say that is E plus. The another force is due to this one. Let us say E minus. So, E plus is definitely greater than E minus. Why? This is nearer. Right. Now, what is the resultant force? So, E plus, because of E plus, it wants to go away. Because of E minus, it wants to go towards minus Q. The resultant of these two is equal to E. E is equal to E plus minus E minus. Now, what is E plus value? So, let us write E plus. E plus is equal to 1 by 4 pi epsilon naught. I am using the formula E is equal to 1 by 4 pi epsilon naught Q by R square. Now, let us say that point P is at a distance of D from the center of the dipole. Is this clear? Right. So, all the time you are supposed to measure the distances from the center of the dipole. So, this is the center of the dipole. The distance between O and P, let us say D. Is this clear? Right. Now, the formula is E is equal to 1 by 4 pi epsilon naught Q by R square. Now, first let us write E plus. E plus is the force acting between this and this. So, that is equal to 1 by 4 pi epsilon naught. So, Q by distance square. What is the distance? This is the distance. But I can't have any parameter to measure it directly. So, indirectly, this distance, that is R, is equal to D minus A. Total D minus of this one. So, this is D minus A whole square. That's all. This distance I want. Now, in the next case, I want this distance. So, that is E minus. E minus is equal to 1 by 4 pi epsilon naught Q. This distance is D plus this A. So, this can be written as D plus A whole square. So, this is greater than that. The resultant is E is equal to E plus minus E minus. So, 1 by 4 pi epsilon naught is common. Even Q is also common. Q by 4 pi epsilon naught. A very small mathematical jugglery is required. This is 1 by D minus A whole square minus of 1 by D plus A whole square. If you know simple mathematics, you can do it. So, this is equal to Q by 4 pi epsilon naught. Here D plus A whole square minus D minus A whole square divided by D square minus A square whole square. So, expand it, you will get D square plus A square plus 2dA minus D square minus A square plus 2dA. So, this will become Q by 4 pi epsilon naught. This is 4dA by D square minus A square whole square. So, I can write 2AQ as P. So, P is dipole momentum, small p, 2AQ. So, this can be written as E is equal to 1 by 4 pi epsilon naught, 2AQ is P. So, this will end up with 2PD by D square minus A square whole square. If you write this much, you will be getting 4 marks. So, these two questions, this question and the next upcoming questions are based on pure mathematics. I think it is clear. Is this clear? Let us go to the next question. Next question is the intensity of the due to electric dipole, but on the equatorial line, right? So, this is the question. Derive an expression for the intensity of an electric field at a point on the equatorial plane, that is the equatorial line of an electric dipole. So, I am drawing the diagram for your purpose. This is minus Q. and this is plus q. So this is the equatorial line. On this equatorial line from the center at a distance d, I am placing a positive charge, that is unit positive charge. So this is the unit positive charge. Let us say this is point P. So what happens? This unit positive charge is repelled by positive charge. So this forces it to go away from it, and this attracts, so it wants to come toward this. The resultant of two forces, this is E1 and this is E2, is this one. So I am supposed to derive the expression for E. Remember, both E1 and E2 are equal. Why they are equal? Charges are same, magnitudes are same, and distances are same. So what is the total length? This is 2a. This is 2a, so this is a. This distance is d. Now what about this distance? This is from Pythagoras theorem. This is d square plus a square. Square of the base and square of the height. Then you will get the square root of the hypotenuse, right? Or this square plus this square is equal to that square. Is this clear? Right. Even here also, this is d square plus a square. That is the reason why both E1 and E2 are equal. Their values, that is equal to 1 by 4 pi epsilon naught q by square of this distance, that is simply d square plus a square. Once again I will do, but roughly I am telling you, right? So we will be doing it in detail. So once again I draw the diagram. This is minus q and plus q. Is this clear? Right. So this is the equatorial line. This is point P. So connect these two. Extend this and extend this. So this is the resultant. So this is E plus and this is E minus. Let the angle be theta. If this is theta, then this is also theta. If this is theta, even here also it is theta. This is equilateral triangle, right? So this is A, and this is D, and this distance is d square plus a square. Is this clear? So both E plus and E minus are equal. So that is equal to 1 by 4 pi epsilon naught q by simply d square plus a square. But I want E is the resultant force acting on P, that is on unit positive charge. So since this is theta and this is theta, the resultant of that resultant E is definitely equal to the sum of the horizontal components, horizontal component of E plus, horizontal component of E minus. In vectors, horizontal component of A, vector A is equal to A cos theta, right? So this is E is equal to E plus cos theta plus E minus cos theta. Both are acting in the same direction. So this one and this one are acting in the same direction. So simply it is 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught q by d square plus a square times cos theta plus cos theta. That is 2 cos theta. So E is equal to 2q cos theta. Is this clear? Divided by 4 pi epsilon naught d square plus a square. You should be in a position to write the value of cos theta. From this triangle, take this triangle, write the value or expression for cos theta. So cos theta is equal to adjacent is A, this one, divided by hypotenuse is d square plus a square. Substitute that here. So instead of writing cos theta, you have to write this 2q by 4 pi epsilon naught times A by under root d square plus a square and one more d square plus a square is there. So here power is 1, here power is 1 by 2. 1 plus 1 by 2 is 3 by 2. I can write E is equal to, this 2AQ is P, simply P in the numerator, and in the denominator 4 pi epsilon naught d square plus a square whole to the power of 3 by 2. If you derive this much, I will be getting 4 marks. Right? Practice. Out of these two questions, definitely you will be getting one. It may be axial line question or it may be equatorial plane question. Okay? Thank you. Let us go to the next question. Now, state Gauss law in electrostatics and explain its importance. It's very, very easy in the case of BPC people to answer this question because there is no mathematical derivation. It's a simple question. Now, if you write the definition, you will be getting 1 mark. Write the expression for the definition, that is Gauss law, 1 mark. Write any two important applications, then you will be getting 4 marks. So, state Gauss law in electrostatics, like Coulomb's law, Gauss law as its replica in magnetostatics also, right. So, what does it say? Suppose there is some charge, let us say plus Q, from which field lines are coming out. I construct a closed loop around this charge. Then the total number of field lines is nothing but electric flux. You might have studied. So, electric flux is indicated by pi E. The total electric flux, that means total field lines coming out from that closed surface is equal to 1 by epsilon times the total charge enclosed by the closed surface. Suppose there are many charges. So, Q1, Q2, Q3, you have to take the net charge. They may be, some of them may be positive, some of them may be negative. That means you have to take the algebraic sum. Like, so we write sigma Q. Sigma Q can be Q1, Q2, minus Q3, Q4 is minus, and so on. That is called the total charge. Total charge is nothing but the net charge. So, whatever the charge enclosed by that closed surface. Is this clear? Right. The electric flux coming out from an enclosed surface is equal to 1 by epsilon times the total charge enclosed within the surface. So, electric flux coming from any closed surface. So, this can be written as the statement to get 1 mark. The total electric flux coming from a closed surface is equal to 1 by epsilon naught times the total charge. This is the statement which carries 1 mark. So, this can be written as pi E is equal to surface integral E dot ds. This is equal to 1 by epsilon times Q net. If you write this much, you will be getting 2 marks. So, what are the applications of Gauss law? What is the importance of Gauss law? So, importance, valid for any closed surface of any shape and size having symmetry. So, by making use of Gauss law, I can find the intensity of electric field. I can calculate potential due to some charge distribution. I can also extend it to find the capacitance. Suppose there is a charged sphere. Now, I want to find the value of E at this point. So, what I do? I construct a Gaussian surface which is identical, similar to the original charged sphere. Then I apply Gauss law. Then I will find the intensity of electric field at this point. I will also find the electric potential at that point. So this dotted structure, enclosed structure, is called as Gaussian surface. You can draw Gaussian surface around any charge distribution having any shape and any size. And you can extend that surface up to there to find E or V values. So, valid for any closed surface of any shape and size having symmetry. Symmetry means it must be similar to the original one. That is called symmetry. For example, you have a cylinder, then I draw another Gaussian surface similar to this, another cylinder. Is this clear? That is called the symmetry. Applicable to any distribution of charges within the closed surface. You may have number of charge distributions within the same Gaussian surface. Is this clear? So, you will be getting 4 marks. Next question from next chapter, that is electrostatic potential and capacitance. Is this clear? So, in the previous chapter, I discussed 6 questions. Out of 6 questions, you will be getting 3. So, even in this also, there are 6 or 7 questions. From this, you will be getting 3 definitely. So, from this video lesson, you are going to get 24 marks. Is this clear? Right. Derive an expression for the electric potential due to a point charge. Electric potential, how it is defined? So, electric potential is nothing but the work done in bringing a unit positive charge from infinity to a point of the electric field against to its wish. Against to its wish. What does it mean? I will explain in detail. Suppose there is a big positive charge here. I want to bring a small positive charge from infinity, from somewhere, to a point P of this field of this capital Q. So, I am trying to bring a small q to a bigger q. And that small q is being repelled. It doesn't want to come here. I am only pushing it. So, in order to bring this from that distance to this distance, I have to sweat. I have to do a lot of work. So, whatever the work done against the wish is stored as potential. Even in gravitational potential also. So, there is a stone on the mountain. If I kick it simply by applying small force, it will come down. But taking the stone from the beneath of this mountain to the top of the mountain, I have to do lot of work. That work is stored as potential. So, this is also potential. So, potential is nothing but the work done in bringing a unit positive charge from infinity to a point P of the electric field. So, that work is nothing but potential. So, in general, potential V is defined as W by Q, where Q is the charge which is being brought from the infinity. If I am bringing a unit positive charge, then this Q becomes 1. In that case, V is nothing but my work. Right. So, this is very simple derivation. It requires some small mathematical knowledge. Then you can get the 4 marks. Right. So, you have to write the definition first. So, there is a plus q, a big Q. I am bringing a small q to this point P. So, a small positive q is approaching, forcibly coming towards big Q. Is this clear? Right. So, that work. So, meanwhile, let us take a small distance dx. So, I am trying to move it from this point to this point, that is dx. So, you know work is f dot dx. So, I am taking many such small dx, so I have to integrate. So, this is negative, the work done against to its wish. So, this work done is nothing but potential. So, what is F? From Coulomb's inverse square law, F is equal to 1 by 4 pi epsilon naught. Q1 is capital Q, and if I take unit positive charge, the second one is 1, and the distance is, let us say, x square. Is this clear? Now, I want to move it further by further a small distance dx. Then, so here dx indicates the distance between these 2 points. So substitute this. So V is equal to negative of, I am bringing it infinity to a point x. So F is 1 by 4 pi epsilon naught q by x square times dx. So q is a constant, 1 by 4 pi epsilon naught is a constant. They can be taken out of the integral. So this is q by 4 pi epsilon naught integral x to the power of minus 2 dx. So I am bringing it from infinity to a point x. Or if you want, you can write r also. You are bringing it from infinity to a distance r. Whatever you want, you can. So let us go to mathematics. There is a formula in integration. X to the power of n dx is equal to x to the power of n plus 1 by n plus 1. Is this clear? So in the previous we had x to the power of minus 2 dx. So its value is x to the power of minus 2 plus 1 by minus 2 plus 1. This is nothing but minus x to the power of minus 1. This is nothing but minus 1 by x. Is this clear? So substitute this in the previous frame. So this is q by 4 pi epsilon naught minus 1 by x infinity to r. Substitute the upper limit minus lower limit. There is already some negative is there. So negative will become positive. So V is equal to 1 by 4 pi epsilon naught. This is q times. First 1 by x is 1 by r and second one is 1 by infinity. 1 by infinity is 0. So you will end up with 1 by 4 pi epsilon naught q by r. This is the potential due to a point charge. If you derive this, you will be getting 4 marks. You have to practice. If you don't practice, simply read it like a newspaper, you will end up with some other answer, or you will be stuck in the middle of the derivation. Is this clear? Right. Now let us go to the next question. Derive an expression for the potential energy of an electric dipole placed in a uniform electric field. One more time, uniform electric field having parallel electric lines of force. Potential energy, just now I told you, the energy is, the work done against to its wish is stored as potential energy. You are familiar with an electric dipole. Is this clear? So, there is a uniform electric field. In this field, a dipole is placed. Right? So, dipole wants to move in this direction, but you are moving it in the opposite direction against to its wish. That work done is stored as potential energy. So, negative of the work done is stored as potential energy. Is this clear? That we have to derive. Now, W is equal to, in rotatory motion, work done is equal to tau dot t theta integral, like f dot ds in linear motion. So, similar to force is tau. Tau is nothing but torque. This is called torque, or what do you call moment of a force. Tau times d theta. So, I am rotating it by an angle small t theta, infinitesimally small, like dx in linear motion. So, this is negative integral of tau d theta. This tau is nothing but couple. So, just now we derived in the previous question. So, tau is equal to P E sin theta. We wrote there as P cross. So, you substitute it here. This is integral, P E is constant. So, P is small here. P E, this is sin theta d theta. Sin theta d theta. So, you should know in integration sin theta d theta is equal to cos theta. Sorry, integral sin theta d theta is cos theta, right? Let us use this in the previous thing. So this is, so u is equal to minus pe cos theta. Here integral must be taken from theta 1 to theta 2. So this is cos theta, substitute theta 1 to theta 2. Then you will be getting u is equal to minus p e cos theta 1 minus cos theta 2. Suppose initially it is at 90 degrees, then I moved it in the opposite direction to another angle theta. So in this case, so theta 2 I have to put 90 degrees and theta 1 is equal to simply theta. Up to here this is enough in the examination. So this will become u is equal to minus pe, here cos theta 1, this is cos theta, and cos theta 2 is cos 90, that is 0. So you will end up with u is equal to minus pe cos theta. Here two things you should remember. One is work, here the work is done by the external agent. I am rotating it from its initial position to in this direction, not in this direction. Is this clear? Right. So you can write this as in vector notation as u is equal to p dot e, dot product. No need, if you write up to this, that is enough. Okay, let us go to the next question. From this chapter also you are going to get 3 questions. So this chapter is also very, very important. So combinedly I am doing this video so that you can score 24 out of 24. Derive an expression for the capacitance of a parallel plate capacitor. You should know capacitance, you should know parallel plate capacitor. A parallel plate capacitor consists 2 parallel plates. This is plate 1 and plate 2. They are parallel to each other. Their areas are equal. They are identical. The distance of separation between them is d. So any parallel plate capacitor consists 2 metallic plates of same area placed parallel to each other and separated by certain distance d. Is this clear? Right. So one plate will be charged positive and the other plate will be charged negative. So even charges on them are also equal, plus q and minus q. This combination is called parallel plate. That is the reason why the symbol for this is drawing 2 lines of same length. So this is plus and this is minus. This is the symbol for a capacitor. Is this clear? Now, capacitance is given by C. So, Q is equal to CV. You should remember, C is equal to Q by V. Charge over the potential of a conductor. The ratio of charge and the potential of the conductor is called capacitance. These are the basics you are supposed to know, right? Now, we will try to derive it. The formula or the expression for the capacitance due to a parallel plate capacitor. Now I draw 2 horizontal lines. So this is positively charged plate and this indicates negatively charged plate. Now field lines, since it is positive charge, so field lines go away from positive charge. These are due to plate 1. Now take the plate 2. To plate 2, field lines go towards the negative charge. Go towards the negative charge. They come all the way. So these are the 2 plates. This is the interior, this is the above the first plate and this is below the second plate. So these 2 cancel each other. So resultant field outside of the capacitor is 0. Even here also they cancel due to first and second, they are opposite in direction. Intensity of electric field outside of the capacitor is 0. But here they are adding up. So this is E1 and this is E2. So the resultant electric field in between the plates is equal to E1 plus E2. The expression for the E due to a charged plate, this is a charged plate for example, is given by E is equal to sigma by 2 epsilon naught. You are supposed to remember this. There is a derivation in the textbook even for this also. If you want, you can see my previous videos done on senior intermediate syllabus, not under mark scoring videos. What is sigma? Sigma is called as surface charge density. So charge by area. What is the area? Area of each plate, just now I told you, capital A. So it can be written as Q by A. You should know all these things, right? So E is equal to E1 plus E2. So E is equal to sigma by 2 epsilon naught plus sigma by 2 epsilon naught. This is E. So this will become sigma by simply epsilon naught. 1 by 2 plus 1 by 2 is 1. What is sigma? Sigma is Q by A. So Q by A epsilon naught. This is the expression for the intensity of electric field between the two plates of a parallel plate capacitor. Is this clear? Now, there is a relationship between E and V. V stands for voltage. That is E is equal to V by D. What is D? D is the distance between these two plates. A is the area. Q is the charges on both the plates. So, now I get V is equal to ED. What is E? Q by A epsilon naught. So, this becomes QD by A epsilon naught. Just now I wrote the expression for C. Or somewhere I wrote C is equal to Q by V. So, C is equal to Q by V. What is V? This substitute. Q by QD by A epsilon naught. So, Q gets cancelled. Then you will end up with C. C is equal to epsilon naught A by D. If you derive this, you will be getting 4 marks. Is this clear? Right. Let us go to the next question. Explain series combination of capacitors. Derive the formula for equivalent capacitance in each combination. Now, what do you mean by series? There are 2 or more number of capacitors. This is plus, minus, plus, minus, plus, minus. The negative plate is connected to the positive plate of the other capacitor, then that combination is called as series. Plus is connected to minus. If all the plus plates are wired together and all the negative plates are wired together, then that is called parallel plate capacitor, right? So, I connect this to a battery of potential V. Current I is going. Remember, in series combination, Q or I constant, current or charge are constant. In parallel combination, voltage is constant. If you remember this, you can do this in a simple way. So, current is same. So, this is the first capacitor, capacitance C1, second capacitor, third capacitor. I am taking 3. The voltage is not same in the series combination, but current is same. So, same current flows. So, same current comes out. But voltage gets divided, V1, V2, V3. Voltages are not same, current is same. You remember that, then you can do. So, what is V? The total voltage, that is equal to V1 plus V2 plus V3. Just now I told you a formula, remember Q is equal to CV, V is equal to Q by C. So, this side, this is Q by C. Is this clear? Next, this is equal to V1 is Q by C1 in the case of first one, plus in the case of second one Q by C2, in the case of third one Q by C3. Q is common on both sides, so you can write like this: Q times 1 by C is equal to Q times 1 by C1 plus 1 by C2 plus 1 by C3. Q gets cancelled. What is the final expression? Derive formula for equivalent capacitance. So, equivalent capacitance is 1 by C equivalent is equal to 1 by C1 plus 1 by C2 plus 1 by C3. If you have more, you have to write more, but for the sake of derivation, you have to take only 3. Is this clear? Right. Next, we have parallel combination. Right. Explain parallel combination of capacitors. So, just now I told you, take 3 capacitors of C1, C2, C3. All positive sides are connected to the same terminal of the battery, and all negative plates are connected to the negative terminal of the battery. So, this is positive combination, parallel combination. So, in parallel combination, voltage is same. So, voltage is same, but current or charge gets divided. So, here charge Q1 flows, here Q2 flows, here Q3. All 3 branches will meet once again, they give out Q, same Q. So, what is divided? That you have to write as a statement. The first step, Q is equal to Q1 plus Q2 plus Q3. But Q is equal to CV. V is the total voltage V, which is same on all the capacitors. So, CV is equal to here C1V plus C2V, C3. V is common on both sides. So, CV is equal to, V can be taken as common, C1 plus C2 plus C3. So, V gets cancelled. You end up with simply C is equal to C1 plus C2 plus C3. What does it mean? In parallel combination, the equivalent capacitance is equal to sum of the individual capacitances. If you derive this, you will be getting 4 marks. Very simple. Now, derive an expression for the electrostatic potential energy of a system of 2-point charges and find its relation with electric potential charge. What does it mean? Suppose there is a charge Q. It has some field. So, into this field, I am bringing another charge to point P. Let us say the distance between these two is x. I have to do some work. The work done against its wish is stored as potential energy. So, what is the work done? So, we know V is equal to W by Q. So, W is equal to VQ. What is V? V is the potential due to a point charge Q. So, W, this is nothing but U. This is V is 1 by 4 pi epsilon naught Q by X and times Q, small q. That's all. If you write this much, you will be getting 4 marks. The final expression is U is equal to 1 by 4 pi epsilon naught big Q times small q divided by X. That's all. The work done in bringing small charge Q into the field of big charge Q against its wish is stored as the potential energy. Very simple. If you remember this, that is enough. Is this clear? Right. Only 4 steps, 4 marks. Now, the last question I think. Explain the behavior of dielectrics in an external field. What do you mean by dielectric? Dielectric means insulator. This pen is an insulator since it is made of plastic, rubber, glass, pure water, paper, thermocol, all are insulators. What happens to these insulators placed in a uniform electric field? The best way to get uniform electric field is place those, let us say this is the rubber sheet, is placed in between the two plates of the capacitor. So these two plates of the capacitor produce uniform electric field E. So that is the meaning. In an external field means placed in between the plates of a capacitor. So dielectrics are of two types. Insulators are of two types. One is called polar dielectrics. The other one is called non-polar dielectrics. How they behave in the external field. Are you following? If I place such substances in between the plates of a parallel plate capacitor, what happens within them? That is the question. Simple explanation, no derivation, right? So I am placing a rubber or some glass slab or something, mica or something. So I am studying their behavior. What happens at their atomic level? So what do you mean by polar substances and non-polar substances? First let us take non-polar substances. What do you mean by non-polar? That means they don't have dipoles. No dipoles, non-polar. Having inherent dipoles, polar. For example, H2. H2 is a non-polar substance. Oxygen is a non-polar substance. In the case of non-polar substance, what happens? Within the atom, both positive charge and negative charge coincide. The center of positive charge and the center of negative charge coincide. So, resultant charge is 0. No dipoles exist. That is called non-polar. In the case of polar substances, for example, in the just now in previous questions, I gave the example of water. In non-polar substance, the bonding is in between H plus and OH minus. So there is a small positive charge and a small negative charge separated by a very small distance of the order of angstroms. So there is a dipole. A positive and negative equal charges are separated by certain distance. Right. In polar, what happens? In polar dielectrics, atoms are having natural dipoles. Little positive charge and little negative charge. Right. Is this clear? Now, what happens to them when they are placed in the external field? Right. When this is placed in the external electric field, what happens? When this is placed within the electric field, that means this is positive and this is negative. Due to electrostatic induction, this positive charge pulls the negative charge towards this, and this negative plate pulls the positive charge towards it. So, this will become slightly elongated, and a negative charge is created here, a positive charge is created. Previously, they were coinciding at the same point. Now, slightly separated. So, dipoles are created. So, when I place a non-polar substance in between the plates, then I will get a small dipoles. So, here negative, positive, negative, positive, negative, positive. So, in between these charges, they cancel each other. If this is a rubber slab or some slab, then I will see negative charges on this side, few positive charges on this side. The applied electric field E, the induced field is a small field is opposing, that is called induced field. So, the resultant field become E minus EI. So, this external field is opposed by a small field, very small. Because the dielectric is getting polarized. Some surface charges are induced. Is this clear? So, this is the behavior of a non-polar dielectric placed in the external electric field. Now, I place a polar dielectric. What happens? Polar dielectrics, they have positive and negative charges, that means dipoles. But let us indicate it by an arrow. So, if I take a non-polar substance at room temperature, all these dipoles are randomly arranged due to thermal agitation. That means, if this is a dielectric, in this the dipoles are randomly arranged in all possible directions. What is the resultant dipole moment, or what is the resultant electric field? The resultant electric field is 0. Now, what I do? I apply external field. That means, now I place this slab in between the plates of the capacitor. As soon as I place this slab in between the plates of the capacitor, then these atomic dipoles, they realign in the direction of external electric field. This is the external electric field. So, all these dipoles will arrange in this direction. Previously, they were randomly arranged. Now, they are realigned in the direction of external electric field. Because of this, some negative charges are, let us say this is this direction. So, arrow plus and the tail is negative. So, you will have some negative charges here and positive charges here. Even in this case also, there are some surface charges which are induced. So, external field is in this direction, the induced field is in this direction. So, in this case also, we write E minus E. Just you have to discuss the behavior under these two categories, then you will be getting 4 marks. So, these are the around 12 to 13 questions, from which you are going to get 6 definitely. So, in turn you are going to get 24 out of 24. Hopefully, you will utilize my video in scoring 24. Thank you very much.